Hello everyone, my name is Jesse Bukenberger, and I will be looking at the facility's impact on system efficiency at a power plant's material handling center. We'll call it ABC Power Plant for now. So if you haven't seen my last PowerPoint video that's online, a little bit of introduction to the problem. There's a power plant that's seeking to reduce the cost of utilities for its customer base, and it's planning on doing that by improving efficiency at its material handling center to reduce costs overall and to pass that on to the customers. So the official problem statement is reduce the material handling cost by improving the efficiency at the facility layout. A little bit of a typo there. So the way I'm going to go about doing this is by generating several facility layouts, including the one that they currently use, and calculating the travel distances from the pickup and drop points to each location in the warehouse. And then I'll run a simulation on all the factors that are under consideration under different layouts, and then generate some statistical tests using a neural network to evaluate the changes. And then I'll use economic analysis to make a 5-year ROI with net present value to make a final decision on the best alternatives. So the 4 different layouts that we've got here, the standard layout, which is right up here, the one they currently use, has manual pick items on shelves, and on top of that has forklifts. So because of this, the aisles have to be pretty wide, 12 feet, and there are manual items and forklift items throughout the factory. One alternative I looked at is the fishbone diagram down here, which found in the literature. Seems to be a pretty efficient design. It's a little unorthodox, so it's a pretty uncommon design. And this would use the same stuff. It would have forklift pallets on top of the shelves with the items in it. And then I'll look at separating the manual pick items and the forklift items. So here in orange is the forklift items, and the gray shelves, there we go, lost my mouse for a second. The gray items are manual pick ones, and the same scheme down here, forklift in back, manual pick items in front. And one reason to do this is because the manual pick aisles are a lot narrower, so you can fit a lot more stuff in them up close and up front. So moving on to how accessible the items are in each of these designs. This is the cart accessibility design. So on the x-axis we have the percentage of how close this item is. So the absolute closest items are down here, and the absolute farthest away are up here. This is the last item you'd find, and on the y-axis we have the distance. So as we can see, the closest item is pretty close to 0 for all the different picking systems, and the farthest item that you have to get is up to 550 feet away for this particular warehouse, which is 400 by 300 feet. And for some designs, like the back lift cart, which is the one with all the forklifts in the back, it's a pretty significant difference between the standard design. Of course, this is just for the cart, and as we can see, the first half of the items are pretty close. There's not a lot of difference between each of the designs, and as I'll get into, organizing the items to put the most frequently used items up front is one of the more crucial changes that I'd recommend. And as you can see, all of the designs are pretty similar in that region. You only see a difference when you get to farther back in the inventory. The forklift is a little bit different. The back forklift design, obviously, none of the forklift stuff is very close at all. And the reason this is designed like this is because it's a lot faster to drive a forklift to the back of the warehouse than to walk there yourself. The fish bowl, which is what I'm calling the balanced design because it looks kind of like a fish bowl, didn't use anything in the corners, which is the farthest place, so you have a lot. It's a very accessible design for both the cart and the forklift, a little more so for the forklift. And then the standard and the fishbone, as you can see. So what I did with those is I plugged them into a simulation for the whole warehouse to determine how long it takes to store and retrieve the items. So the way the simulation works is we generate orders, and then we determine where their location is in the warehouse. So there's 2 alternatives to that. There's just randomly dispersed throughout the warehouse, and there's organized, so the more frequently used items are up close to the front, so most of the items that are in the simulation are easily accessible. From there we just determine if it's a cart or a forklift item, and wherever they are, they go to the same process. They wait in the queue for the next available cart or forklift, and then they're processed by the cart or forklift depending on how far away they are, and then they exit the system and we collect statistics on that. So there are a lot of factors with that, whether the inventory is organized so it's close to the front or not, ABC style. The warehouse layout, there's the 4 different layouts that I went over, and the number of forklifts and carts, so the various levels for that. And then the level of activity, so if the warehouse is really busy or if it's maybe not so busy for a day. That comes out to 480 scenarios with 5 runs each. I'm very glad I don't have to manually look at every single different configuration in a warehouse. That's why we love simulation. And then we're going to look at the response measures for the forklift and the cart, the travel time, the utilization, and the wait time of the items wanting to use that mode of transportation. So for the analysis, this graph is probably pretty tough to see, but this is the forklift travel time, this is the cart travel time, based on whether or not the inventory is divided by, or is organized or not. So this is not organized, this is organized, and for each of the 4 different layouts. So this is the forklift items in back, this is the second one here is the fish bowl one, or the balance design. The third one is the fishbone, and finally the standard warehouse layout. So what we can see with this is that organizing the inventory makes a little bit of a difference for the forklift, but a much bigger difference for the carts. That's mainly because the carts take a lot longer to walk wherever they're going, so if they don't have to walk as far, it really affects the average. And as far as the different designs, the fishbone's a pretty good alternative for both of them, but the fish bowl effect is a little even better for the forklift, and it's still an improvement for the carts. The forklift in back is very good for the carts, but it's also the worst for the forklift. The next graph looks at the number of forklifts versus how busy the factory is, and its effects on the forklift wait time or the number of carts on the cart wait time. And what we can see from this is that as you improve the number of forklifts, you don't really improve the wait time of things very much. It's more dependent on how busy the factory is, and we'll get more into how the forklifts impact things later, but as you can see, it's not really, throwing more forklifts at the problem doesn't really fix it when you compare it to the carts. When you have the carts, if you put more carts on it in a given day, you see pretty significant changes with each cart from in the wait time of things. So if you have the maximum number of carts, you have almost no wait time, but if you have one fewer cart, you have a little bit more of a wait time, and one fewer, a little bit more. It's pretty, each cart changes it, whereas with the forklifts, it's, maybe that last one there made a change, but otherwise not really. It's kind of, you have to have the right number of forklifts, but the other factors play a bigger part in that. And that graph really shows this. This is the utilization of the forklifts or the carts versus the layout design and the forklift, the number of forklifts. So as you can see, as you get more and more forklifts or fewer and fewer forklifts, the utilization really doesn't change very much in a given layout. But if you have a much more efficient layout, so this is the forklifts in back and this is the balance design, that really changes the forklifts layout, or the forklifts utilization. So that kind of shows that that's a little bit more important for the forklifts, the layout. Whereas with the carts, it's the other way around. The different layouts don't really change the utilization very much. Maybe the standard one is the worst by a noticeable amount, but for the most part, the number of carts you have working is what really changes their utilization rate. And so this kind of implies that the layout is really, you should cater more to the forklifts because they're the ones that benefit from it, whereas the carts, it's kind of, the number of carts is really still what's important. So putting that into economic terms, we'd recommend choosing the balance design because it is an improvement for the carts and the forklifts, and it improves both of them, which the backlift design didn't really. It made things worse for the forklifts, which is who benefit more from a good design, and the carts didn't really change much for them. The fishbone design was good as well, but it's a little unorthodox, so I think it would be a little less likely to be embraced by everyone involved. So that one, second place, but it's still a feasible design, although it is still worse technically as well. So what that comes down to for the economics is the forklift travel time reduction comes out to about 28%, the cart travel time reduction comes out to about 35%, and we freed up 4% of the facility space, which isn't a whole lot, but it's a pretty big facility, so you could put something in 4%. And that comes from taking the forklift items off of the top of the shelves and cramming the manual items a little closer together as far as the shelving, or as far as the aisle width goes, which was still pretty lenient. It wasn't like they were crammed in there in the dark. So that comes out for a 5-year net present value return on investment of 32%, but this is very dependent on the cost of implementing everything, whether or not we can recycle the shelving for the forklifts, or if we have to buy new stuff. That could really make or break whether or not this project is feasible right there. But as it is now, the estimates say 32% ROI over 5 years. So in conclusion, organizing the inventory is a very important part of it. I won't say it's quick and easy because a lot of work goes into optimizing where everything goes, but without changing any of the shelving layouts, you can see pretty big improvements just by organizing the inventory by how frequently it's used. I would say separate the forklift aisles from the hand cart aisles to give you better space utilization and also improve how close things are to where you need them, which improves the efficiency in general there. And the balanced design is probably the best with that. I mean, it's tempting to put the forklift stuff in the back because you can just zoom out there at 20 miles an hour or something. When you have to walk out there, it's a lot slower. But in reality, the forklifts benefit from having a good design more than the carts do because the carts are so slow. It's kind of counterintuitive. And again, the benefits of the whole project are largely dependent on how expensive the implementation is. It's a pretty wide range that it could cost depending on how much of existing materials can be recycled. So we could have a huge ROI or it could be negative and not worth doing at all. So that needs to be looked into slightly more. But otherwise, seems like a good project. So here are some references which you can't see. I look forward to seeing you all later.